Everyone. So today we are going to talk about multi-threading in C#. Okay. Um, so till now, like whatever applications and pieces of code that we have written, we have been working on a single threaded applications. So basically, when you run the application, there's only one thread that is created, and everything the processing happens uh, in a sequential manner. So there can be a scenario, and especially in these days, because the processors that we have, they have a lot of they have multiple cores, so we can leverage multi-threading in C sharp if you want to do some parallel programming. Okay, and so I'm going to showcase like how you can create threads in C sharp and how you can leverage the whole infrastructure that we have. But there's also a lot of fundamentals that you should be knowing. Probably I'll have like create another session just to cover the basics of multi-threading. What's the difference between a process and a thread, and how do we deal with thread communication and process communication. Okay, so today we'll try to keep it simple. We'll just see like how we can create threads manually in C sharp, and we'll see like how we can make use of multi-threads to simulate parallelism in C sharp. All right, so let's say so we have this class program class here. We have a static method. What I'll do is I'll create another static method here, right? So I'll create something called as, I'll say static void do some. So in this method, let's say we have a for loop. Say int I equals to 0, I less than 10 plus. So I want to simulate that, okay, we are doing something compute intensive, which takes a lot of time, right? So there could be something a lot, basically you're running an algorithm which takes a lot of time. So in order to simulate that, probably I'll just print out. What I'm going to use here is something called as a sleep method, which so I can say, and it takes in a parameter which is of I think it's milliseconds. So I'll just say 1000 milliseconds, which is 1 second. Oh, what would happen is if I call do some work, it's just going to loop through this loop from 0 to 9 and then print that number on the screen and also do a sleep for 1 second, right? So this should probably after each second just print out the value of I on the UI. So let's just call this do some work from this main method, right? So I'll just say start. So it starts to print out 0, 1, 2, and this would just go till 9. Okay, very straightforward, right? So this is my main method. So what happens is when the program calls the main method, a thread automatically gets created and it would call this method. So the control would go here and this would process this entire method and then come here and wait for us to take in an input, right? And then exit. So there's only one thread that gets created and it's automatically done by the runtime. Right. So now let's say, so this is one piece of work that you wanted to do. And let's say you have another piece of work that you wanted to do after probably, let's say, let's just create another method altogether, right? So I'll just create another method. So I'll just call it as do some other work. In this case, I'll probably start with 10 and just go till 20 and do the same thing, right? I can do is I can just call this method as well. And then I'll start executing this program again. So now this should go from 0 to 9. And then after 9, it will go from 10 to 19. Right? And if you see here, right, the execution is in sequence. So first this method gets called. So initially the main method gets called and then do some work method gets called. and do some other work would get called, and then this statement would get executed and the program would end, right? So now if you want to do these two pieces of work parallelly, right? Let's say these are independent pieces of work and you can afford to do it in parallel. In that, this is like one use case of using multi-threading. Okay, so let's do one thing. So let's create two threads. So I'll say thread T1 equals to new thread. And I'm able to create this thread because I have included this namespace, which is called system.threading. If I remove this, it would give me a compile time error, right? So you have to include this namespace using system.threading. I create a new thread. Now, in order to create a new thread, you have to tell that, okay, if this thread is started, what method would you like to call, right, on this particular thread? So I can say new, it takes in a parameter, an instance of Thread.Start, and then you can pass the name of the method. So in this particular scenario, sorry. Good. So this is our first thread. Similarly, I'll copy this, paste this again, and then call this as T2 and do some work. I'll say do some other work. Okay, so our two threads are ready. Now, if I run this again, what would happen is these two threads would be created, and then actually nothing would happen because we have not started the thread. So for also we have to call these two methods on another separate thread, not on the main thread. So I'll just comment out these two lines now, right? So we don't have to call them on the same thread. So now I'll just decrease this time. I'll just say 100 milliseconds because one second is a lot of time. Now what I'll do is I'll say T1 dot start, and we can say T2 dot start. All right, so now what should happen is thread 1 would be created, thread 2 would be created. So thread 1, as soon as we call thread 1 dot start, T1 dot start, this method would be called, but on a separate thread, right? So this would be executed on another thread, but the control here would come here, right? Now it would say that, okay, see that, okay, we also want to start thread 2, T2 would be started. Then on another thread, this method would be called, right? So there are like three pieces of things happening in parallel. There is this method being called by thread 1. There is this method being called on thread 2, and the main thread, which was actually created automatically by the runtime, this piece of code would be running on that, right? So after that, it would actually come here and wait for us to provide a value. If we press on enter, actually what would happen is these threads would get terminated because they were actually started by this main thread, right? But we would not do that. So let's just give it a start. Now, if you see here, I mean, and this processing would be totally random, right? If I run this program again, even I'm not sure like we would get the same output. If you see here, so the first thread from 0 to 9 was executed, but for the other thread, T2 thread, 10 was the first for loop was uh, ran for the first index, right? That the 10 was printed even before the first thread concluded. So if I run this again, see, thread 2 actually did start first and it printed out 10 on the screen, right? So it's totally on the runtime that when it would start this thread. It's actually we can only say, we can only tell the runtime that, okay, this is when we want you to start the thread, but this you cannot have your application based on like how and when you want to start a thread, right? So this is something that you have to keep in mind. But this is how it works, right? So you can create multiple threads. All you have to make sure is the pieces of work that you're trying to process by these different threads. they are independent to each other. That's the first thing. And second thing is that the main thread, which actually creates those thread, and then you start those thread, you have to manage the life cycle, right? If you want to wait here till other threads complete, so those are sort of things. And also, if you want to communicate between threads, that is something that you have to take care of, right, while writing your program. And the last thing is, if you're writing a multi-threaded program, it's very difficult to debug it, right? Because there are multiple threads into picture. So you would always know in the debugger you'll see that, okay, the control is actually here, but that control is actually for one of the threads, right? Probably at the same time for thread 2, the control could be here, right? So somehow, right, debugging multi-threaded applications is a bit difficult, right? So you have to be very careful while working with multi-threaded applications. So I think I just wanted you guys to give a flavor of how multi-threading works in C#. So we'll have more videos dedicated to multi-threading, because there's a lot that we can achieve using multi-threading, and there's a lot of framework libraries as well, which we use these days to help us, right, actually create threads at runtime, rather than we specifying that when to start those threads, etc. And lastly, threads should actually be used to do a compute intensive work, right? Something that the CPU has to process is something that you should uh, do on another thread, right? If you want to make a database call, if you want to call an API, so those kind of works, those are IO bound work. That is not CPU bound work, right? So those kind of works you can use asynchronous programming. We'll also see later on how we can leverage async await to help us solve calling, doing some sort of operation which are IO bound, not CPU bound. Okay. So that's all for today. Thank you for watching. I'll see you on the next video.